Hello, I'm Sarah Habshi, and this is a presentation of the use of mutation in injecting test order dependency. Developers rely on regression testing to ensure that their code changes are not breaking existing features. If the tests pass, it means that the changes can be accepted. And if one of the tests fails, it means that the changes should not be merged and they should be revised. However, a problem occurs when the tests themselves are non-deterministic, which means that for the same exact code, the tests both pass and fail. This phenomenon is called flakiness. Flakiness is problematic because it leads to frequent build failures, which means that the continuous integration is not smooth and a lot of resources are wasted in rerunning the same tests. And in the long run, developers may also lose their trust in regression testing in general. For these reasons, when flaky tests manifest, they should be identified, debugged, and fixed as soon as possible. And ideally, this whole process shall be automated to save the developer's time. However, the efforts to automate these tasks remain limited, partially due to the lack of flakiness datasets, which can serve as examples for learning-based techniques. And for these reasons, we propose Flaky, a mutation-based approach for injecting test flakiness. Our approach focuses on a very specific type of flakiness, which is order dependency. This represents tests that have different results based on the execution order. So our approach takes a stable test suite. Here we can see that in different orders from order 1 to n, the results are the same. The test suite is stable. But if we mutate one of the tests, let's say test C, and then we reintroduce it in the test suite, we can make the test suite order dependent. Here we can see that sometimes the test suite is passing and sometimes we have failures. In this case, the test suite is order dependent and test C prime is flaky. But the question is, what kind of mutation will allow us to make test suites order dependent? We actually focus on a very specific type of statements, which are helper statements. These statements serve as a fixture that sets the proper state for test execution. And here, if we apply a mutation on, for example, the second test, by removing this helper statement, we can make this test dependent on the first one, because the test still needs this fixture to pass. So if we run the test alone, it will fail, but if we run it after the first test, it will pass. So in a way, we made this test flaky. By applying this kind of mutation on a set of open source test suites, we aim to assess the ability of mutation in injecting flakiness, but we also want to create datasets and benchmarks that can serve in flakiness studies.